Everyone thinks the sun is burning. You've known it since childhood. A giant ball of fire suspended in the sky, blazing, endless, unstoppable. That is the image that lives in your mind every time you look up. Something ancient, something familiar, something obvious, but it is wrong. Not slightly wrong, completely wrong. The sun is not burning. It has never burned, not once in its entire 5 billion year existence. And the moment you truly understand what is happening above your head right now, 93 million miles away, you will never look at the sky in the same way again. Because the thing keeping you alive is not fire. It is something far stranger, something so unfamiliar to human experience that language itself begins to fail when we try to describe it. Stay with this idea. For as long as humans have existed, the sun has been a mystery hanging above them. Ancient civilizations did not see it as a physical object in space. They saw it as power, as divinity, as meaning itself. The Egyptians called it Ra, the giver of life, the force that ruled day and night. Temples were built in alignment with its rising. Entire civilizations structured their time, their rituals, and their understanding of existence around its motion across the sky. But even then, one question haunted every culture that looked upward. What is it, and why does it never go out? The Greeks tried to answer. Anaxagoras, in the 5th century BCE, dared to suggest something revolutionary. The sun, he said, was not a god at all. It was a burning stone, an enormous fiery object far away in space. It was a brilliant idea for its time, and he was punished for it, exiled, ridiculed, but history quietly reveals something important. He was asking the right kind of question, because for thousands of years after him, humanity continued to struggle with the same mystery. Philosophers, mathematicians, and theologians all tried to explain the sun's power. Aristotle believed it belonged to a divine fifth element, ether, something beyond earthly physics. Medieval thinkers wrapped it in theology. Scientists later tried mathematics, but none of it solved the core problem. How does it keep shining? And then, by the 19th century, something changed. Science became precise enough to measure the problem, but that precision made the mystery even worse. The sun was now understood not as a symbol, but as a physical object that releases energy. And the number was staggering. Every single second, the sun produces more energy than all of human civilization has ever generated in its entire history combined. Every second, without pause, without decline. And it has been doing this for 5 billion years. That single fact broke every simple explanation humanity had ever constructed. Scientists began searching for answers that matched the scale of the problem. One of the earliest serious ideas came from gravity itself. Perhaps they thought the sun was slowly collapsing under its own weight. As it shrank, gravitational energy would convert into heat and light, a slow cosmic contraction powering the glow of the sun. It was elegant, logical, beautiful in its simplicity, but it failed. When calculated carefully, the numbers refused to cooperate, even if the sun were collapsing. Even if gravity were releasing energy as efficiently as possible, it could only shine for about 20 million years. That sounds long in human terms, but on a cosmic scale, it is nothing. And worse, Earth itself was far older. Geological evidence showed a planet with a history stretching far beyond that limit. Mountains, fossils, rock layers, all pointing to deep time that gravity alone could not explain. This created a crisis in science. The sun's existence had become a contradiction. It should have burned out long ago, but it hadn't. It was still shining, still stable, still powerful beyond comprehension. And so the question deepened. If it is not fire and not gravity, then what is it? At this point, something important must be addressed. The human mind naturally reaches for familiar explanations, and the most familiar source of heat and light is fire. Combustion, burning wood, coal, gas, so it is natural, almost unavoidable, to imagine the sun in the same way. A giant campfire in space, a massive furnace consuming fuel. But this intuition collapses under even basic calculation. Fire is a chemical process. It works by rearranging electrons between atoms. The atoms themselves remain unchanged. This is why fire always needs fuel, and why it always ends. Now imagine scaling that process up to the sun. If the sun were made entirely of coal and burned like a gigantic fire, it would run out of fuel in roughly 10,000 years. But the sun has existed for 5 billion years. That is not a small mismatch. That is a failure by a factor of 500,000. Something about the sun is fundamentally different from anything we call burning. And the difference lies deeper than chemistry. It lies inside the atom itself, because chemical reactions only deal with electrons, the outer layers of matter. But the sun does something far more extreme. It reaches into the nucleus of atoms themselves, where entirely different forces exist. To understand this, you have to abandon everyday intuition entirely. You have to enter a world where particles do not behave like objects, but like probabilities, where barriers can be crossed without being physically broken, where matter can become energy, and where the rules of reality begin to behave in ways no ancient thinker could have ever imagined. Because at the center of the sun, something extraordinary is happening right now. Not burning, not collapsing, but transforming. To understand the sun, you have to go somewhere almost no human intuition has ever truly gone. Inside the atom itself. Forget everything large-scale reality has taught you. Forget fire, heat, and motion as you know them. Inside atoms, none of those rules behave the same way. Imagine a single hydrogen atom. At its center sits a proton, a tiny dense nucleus carrying a positive charge. Around it, an electron moves, not in a fixed orbit like a planet, but as a cloud of probability, existing in a blurred region of possibility rather than a defined path. Now imagine another hydrogen atom next to it. Under normal conditions, they never touch. In fact, they actively repel each other. Why? Because both nuclei are positively charged. And in physics, like charges repel with enormous force at very small distances. This invisible repulsion creates what is known as the Coulomb barrier, a fundamental wall of electromagnetic resistance that prevents atomic nuclei from getting close enough to interact. On Earth, this barrier is absolute in practice. Atoms can collide billions of times every second in a hot environment, and still nothing happens at the nuclear level. They bounce off each other like invisible shields colliding in empty space. No fusion, no merging, no transformation, just endless repulsion. So if this barrier exists, and if it is so strong, then logically the sun should not be able to do anything special either. And yet it does. At the core of the sun, conditions are no longer ordinary. They are extreme beyond imagination. The temperature reaches around 15 million degrees Celsius. The pressure is so intense, it cannot be recreated naturally anywhere on Earth. Hydrogen nuclei are packed together in a dense, violent sea of motion, constantly colliding, constantly accelerating. Under these conditions, something strange becomes possible. Not guaranteed, not predictable in a classical sense, but possible, a phenomenon that classical physics never predicted. A loophole in the structure of reality itself. It is called quantum tunneling, and it changes everything. EMC. 2. Quantum tunneling is one of the most unintuitive ideas in all of physics. In the classical world, the world of everyday experience, if a ball does not have enough energy to climb a wall, it simply bounces back. The wall is absolute, unbreakable, final. But at the quantum level, particles do not behave like objects. They behave like probability waves. And probability waves do not respect classical boundaries in the same way. A hydrogen nucleus approaching the Coulomb barrier does not behave like a tiny ball hitting a wall. Instead, it exists as a spread of probabilities, some of which extend through the barrier itself. This means that even without having enough energy to overcome the barrier, there is still a small chance, an extremely small chance, that the particle appears on the other side, not by breaking the wall, but by passing through it in a way that defies classical explanation. This is quantum tunneling. And inside the sun's core, where trillions upon trillions of hydrogen nuclei are constantly colliding, even an incredibly small probability becomes enough to sustain a massive, continuous process. When two hydrogen nuclei finally manage to get close enough for a different force to take over, something new happens. The strong nuclear force begins to dominate. Unlike electromagnetism, which repels, the strong force binds particles together with overwhelming strength, but only at extremely short distances. So once nuclei get close enough through tunneling, they are pulled together violently, forming new atomic structures. This is nuclear fusion. 4 hydrogen nuclei eventually combine through a chain of reactions to form a single helium nucleus. But something deeply unexpected happens in the process. The final helium nucleus is slightly lighter than the 4 original hydrogen nuclei combined. The difference is small, about 0.17% of the mass, but in physics, nothing is ever just small when multiplied by cosmic scale. That missing mass does not disappear. It transforms into energy. And this is where reality becomes almost unbelievable, because that transformation is governed by one of the most profound equations ever discovered, EC/mc. 2, energy equals mass multiplied by the speed of light squared. And because the speed of light is unimaginably large, even a tiny amount of mass becomes an enormous release of energy. Inside the sun, this process happens constantly. Every second, around 600 million tons of hydrogen are converted into helium. And from that, about 4 million tons of mass vanish into pure energy, not destruction, transformation. That energy emerges as light, heat, radiation, and particles that stream outward in every direction. What we call sunlight is not fire. It is the direct conversion of matter into energy at a nuclear level. Fire is chemical. The sun is nuclear. Fire rearranges electrons. The sun reshapes the nucleus itself. Fire is temporary. The sun is sustained by fundamental forces woven into the structure of reality. And what is most astonishing is not just that this process happens, but that it happens quietly. There is no explosion, no chaos, no violent instability. The sun is not detonating. It is balancing a delicate equilibrium between gravity pulling inward and fusion pushing outward. A stable system that has persisted for billions of years without collapsing or fading. And this stability is why we exist. Because without this quiet, continuous nuclear reaction, there would be no sunlight, no warmth, no chemistry of life, no earth as we know it, just darkness, but instead there is light, a steady stream of transformed mass traveling outward through space, carrying energy that will eventually reach distant worlds, including ours, and in that light, life becomes possible. If you say continue, I'll write, the energy created in the core of the sun does not immediately escape into space. It begins a journey so slow and chaotic that it almost defies imagination. Because inside the sun, light does not travel in a straight line. It cannot. The sun is not empty. It is dense plasma, an ocean of charged particles constantly colliding, absorbing, and re-emitting radiation. A single photon, born in the core from nuclear fusion, tries to escape outward, but it cannot move freely. It is immediately absorbed by surrounding particles, then re-emitted in a new direction. Again and again, forward, then sideways, then backward, then forward again. This process repeats endlessly. What should take only a few seconds in empty space becomes a random, chaotic walk through dense matter. And so the photon begins a journey that takes an extraordinary amount of time. Not hours, not years, but something closer to a cosmic memory. On average, it can take around 100,000 years for a single photon to travel from the core of the sun to its surface. Think about that. The light touching your skin right now was born before human civilization existed in its modern form, before written language, before cities, before recorded history. It was created in a sun that was already ancient when early humans were still learning to shape tools from stone. And after finally reaching the surface of the sun, the photon is released into space. There, everything changes. Suddenly, there are no collisions, no plasma, no resistance, just emptiness. The photon travels in a straight line at the speed of light, 300,000 kilometers per second, crossing the vast distance between the sun and Earth in about 8 minutes. 8 minutes after leaving the sun's surface, it arrives here. It reaches your skin, your eyes, your world. What you call sunlight is not a simple, immediate phenomenon. It is ancient energy, delayed by time, shaped by probability, and released after a journey longer than human existence itself. And yet, when it finally arrives, it feels instantaneous, warm, familiar, ordinary, but there is nothing ordinary about it, because every ray of light is a message from deep time, a physical artifact of processes that began long before humanity ever existed, and it is this light that makes life possible. Once sunlight reaches Earth, its journey is not over. In fact, its most important transformation is just beginning, because light is not just illumination, it is energy. And energy can be used. When photons from the sun strike the surface of our planet, they interact with matter in countless ways. One of the most important occurs in plants. Inside a leaf, there is a molecule called chlorophyll. It is designed, shaped by billions of years of evolution, to capture sunlight. When a photon hits chlorophyll, it transfers its energy into chemical processes. That energy is used to split water molecules and combine carbon dioxide into glucose. This process is called photosynthesis, and it is one of the most important transformations in the history of Earth. because it means sunlight becomes chemistry, chemistry becomes biology, and biology becomes life. The sugar produced in leaves becomes food for plants. Plants become food for animals. Animals become part of complex ecosystems. And eventually, through long chains of transformation, that energy becomes you. Every breath you take, every thought you think, every movement you make, all powered by sunlight that began its journey in the core of a star. Even the energy stored in fossil fuels is ancient sunlight, captured by prehistoric organisms millions of years ago, compressed and transformed over geological time. You are not separate from this process. You are part of it, a continuation of stellar energy expressed in biological form. In a very real sense, you are not just living on Earth, you are living from the sun. This changes everything about how you understand yourself. Because what you call life is not isolated from the universe. It is a direct expression of cosmic energy reorganizing itself into complexity. Your body is not a closed system. It is a transformation engine, a structure that takes in energy, reorganizes it, and produces consciousness. And that consciousness is built from starlight, from nuclear fusion, from processes that began before Earth existed. So when you ask what you are, the answer is not only biological, it is astronomical. You are what happens when a star learns how to think, and in that realization something subtle shifts, because the sun is no longer just a distant object in the sky. It becomes a participant in your existence, a continuous source of the energy that makes awareness possible, a silent architect of every moment of your experience. Now step back, far back, beyond Earth, beyond the sun, beyond even our solar system, because to understand the sun fully, you must understand its context, its place in something vastly larger. Our sun is not unique. It is one star among billions. In the Milky Way galaxy alone, there are an estimated 200 to 400 billion stars. Each one is a potential sun, each one a fusion engine, each one converting mass into light. If you tried to count them, one per second without stopping, it would take you over 6,000 years, longer than all recorded human history combined. And yet, the Milky Way is only one galaxy. The observable universe contains an estimated 2 trillion galaxies. 2 trillion, a number so vast that it stops behaving like a number and starts behaving like an idea we cannot fully hold in our minds. And in each of those galaxies, there are stars, trillions upon trillions of them, all quietly burning, though not burning in the way we once believed, all fusing hydrogen into helium, all releasing energy that travels across space for millions or even billions of years. The universe is not empty, it is overflowing with stars, and each star is a story of transformation. But here is the deeper realization: the light from these stars is not just distant, it is time itself. When you look at a star, you are not seeing it as it is now, you are seeing it as it was. Some of the light entering your eyes tonight may have begun its journey before humans existed, before Earth had its modern shape, before continents looked as they do today. Space is not just distance, it is time stretched across emptiness, and light is the bridge between them, a bridge built from nuclear reactions happening inside stars like our sun. But even this scale, galaxies, stars, light years, is not the final point, because the most important thing is not how large the universe is, it is that we are here to observe it. Now return to the sun, not as a fire, not as a symbol, but as it truly is, a self-sustaining nuclear process. A balance between gravity pulling inward and fusion pushing outward. A star in the middle of its life, quietly converting matter into light. It has been doing this for 5 billion years, and it will continue for billions more. But the most profound truth is not its longevity, it is what it creates, because from this process, this slow, stable, almost silent transformation of hydrogen into helium, emerges everything we know as life. The energy that reaches Earth becomes chemistry. Chemistry becomes biology. Biology becomes thought, and thought becomes awareness. Which means the sun is not just a distant object sustaining life. It is the source of the conditions that allow the universe to become conscious of itself. You are part of that process, not separate from it, not observing it from outside, but made from it. Every atom in your body was once inside a star. Every molecule of water you drink is part of a cosmic cycle. Every breath you take is powered by sunlight. You are not standing beneath the sun. You are participating in it. And when you zoom out far enough, something extraordinary becomes clear. The universe is not indifferent in the way we imagine. It is evolving toward complexity, toward structure, toward observation, toward the ability to ask questions like, what is the sun? Why does it shine? What does it mean that we are here to see it? The sun shines not because it is burning fuel, it shines because the laws of physics allow matter to transform into light under extreme conditions. And in doing so, it creates the energy that makes life possible. So the question was never simply, why doesn't the sun go out? The real question is, what kind of universe creates a star that creates life, that creates eyes, that can look back and understand the star itself? That question does not have a simple answer, but it has a profound implication. We are not separate from the cosmos. We are the cosmos observing itself. And for this brief moment in cosmic time, on a small planet orbiting an ordinary star, you are part of that awareness, a temporary configuration of matter, powered by nuclear fusion, lit by ancient photons, thinking about its own origin. And that changes everything, because the next time you look up at the sky, you will not see a burning object. You will see a process older than Earth, stranger than fire, stranger than imagination, a quiet, continuous transformation of matter into light that makes your existence possible.